In ROS2, when you create a package, you have to select a build type. So if I do ROS2 pkg create with build type, I have those options. I have CMake, Python, and CMake. And well, basically, if you choose this one, you're going to create a C++ package. If you choose Python, you're going to create a Python package. But how to do if you want to create a ROS2 package containing both Python nodes and C++ nodes? Well, good news for you, it's possible, and in this tutorial I will show you how to do that step by step. So the first thing to do is to create our package. And basically what we're going to do in order to host both C++ and Python nodes is we're going to create a C++ package first. So a standard C++ package, and in that C++ package we are going to add some configurations so that we can also install Python nodes. So let's go ahead and do that. So let's do ROS2 pkg create. So I am also in my source repository of the ROS2 workspace, okay, that I have already created and configured before. So ROS2 pkg create, let's name it my custom pkg, and then -- build type with CMake. Okay, good. So I have my custom package, and let's do, so I'm gonna do code dot, I have installed Visual Studio Code. You can just open any text editor you want. And here, so we have my custom pkg, which is a standard C++ package. Okay, we have CMakeLists.txt, package.xml, and then a source and include folder. So now let's create some nodes. I'm first going to create a C++ node, and then we're going to do a Python node, and after that we're going to completely configure the package so that we can install both nodes and use them directly. So let's add a C++ node, and to give you a complete example, I'm going to add first, inside the include my custom package, I'm going to add a C++ header. So let's do right click here, new file, let's name it cpp header.hpp. All right, just any name. All right, and for this I already have written some code here because this tutorial is about configuration. Okay, I'm not gonna show you how to write a node. So we have first, of course, include rcl-cpp, okay, the library, so the C++ library to use ROS2, and then I simply create a class here. So I declare the class in the header. So my custom node, that's gonna be the class which inherits from the node class. And then I have a constructor, and in this constructor what I do is I simply do rcl-cpp info, okay, with test cpp node. So the constructor is just gonna print something, and that's it. For now there is no other functionality in this node, that's very minimal. So I'm gonna save this, and in the source folder here I'm gonna right click new file cpp node.cpp. So I create here a source file, and in that source file I'm gonna add code, that code. So I include the rcl-cpp library, of course, to use ROS2 functionalities. And then you can see to include the header file from the include folder here, I'm gonna do include my custom package. So my custom package is, well, the folder here. Okay, so that's the name of your package slash the name of the header file. Okay, so very simple here. And when we install the node later, we're gonna add something in the CMakeLists.txt so that we can know that this will actually come from the include folder of that package. Okay, so we include the header file, we have a main, so very important here to have a main. Okay, that's not gonna work if you don't have a main function. And then what we do is we simply initialize ROS2 communications, we create the node. Okay, so my custom node, we create it inside the source file, we make the node spin, and then we shut down ROS and we return. Nothing special. So this node will just print test cpp node and then wait until we kill the node. Okay, I'm gonna save this. And now we have our minimal C++ node with a cpp file and an hpp file. Let's now create a Python node. So let's go back to the terminal and let's do clear here. Let's go to our package, which contains for now just C++ stuff. I'm going to add a new directory, so mkdir, which name is my custom pkg, so the exact same name as the package name. If you already know how to create a normal Python package, you know that you're going to put your Python stuff inside a folder that name is the same as the package. So we are going to recreate that also here. And inside my custom package here, so we have the source of our ROS2 workspace, and then we have name of the package, and then another folder with the same name as the package. And here we do touch init. So we create an init file that's gonna be empty, and we just leave it like this. Now in this package, well, I would say that the organization from here can vary. Some people will have different preferences. But what I'm gonna do here is in this package, I'm gonna just create Python modules and libraries that you want to include in your Python nodes, and also in other packages. If you want to add dependencies between packages and modules, you can add your modules right here. And we're gonna create another folder for actually the nodes. So let's create here module to import.py. Okay, and now let's come back to VS Code. So we have so let's close this. So we have my custom package, and inside this now we have another my custom package with init.py, which is empty and which will stay empty for now, and module to import. Let's actually, I'm gonna have some code here. So what do? First, very important, we add the interpreter line, okay? And then what I do is I import RCLPy, which is the Python library for ROS2. And then, well, I just create a node, just like I did with C++. I just create a node in a kind of a header file here that's going to be a module to import. So I create the class myNode, which inherits from node. And then I have a constructor. In the constructor, I just also print test Python. Okay, so this node will do nothing, just print a log. So let's save this file. And now we're going to create an actual file to create the node, okay, because this is the class. We're going to create an instance of the class and make the node spin. So let's come back to the terminal, and I'm going to come back to, so here I am in the package. And so for C++, we have the include for the header file and the source for the C++ file. With Python, we have the folder with the same name as the package to host libraries and module, and I'm going to create a scripts folder. Okay, so in this script folder, we are going to create our Python nodes. And if you were already developing with ROS1 previously, well, that's kind of similar to what we did. Okay, we created a normal package, which was basically a C++ package, and then we added a script folder to host Python nodes. That's kind of similar here. So let's create a Python node. Let's do touch pynode.py. And very important, let's make it executable. So chmod plus x with the file name. Okay, make sure that every Python node you create, you make it executable here. That's gonna help you not to get errors in the future. So we have our new script folder here inside the package with pynode.py, and let's actually write the code. So I have the code here. So what do I have? First, Python interpreter, super important. And then I import RCLPy, and then I import the module from this my custom package folder. So how to import the module? Well, from my custom package, which is the name of the package and also the name of this folder, dot the name of the file, module to import, import my node, which is the class, as you can see that I've created here. So now that I have imported the class, I can create in the main, I can create an instance here, my node. So I have a node, I make the node spin and then shut down when I press Ctrl+C. So very classic here. And that's very important. Make sure that you have a main function, and also make sure that you have this if name is equal to main, and you call the main function. That's what's going to be called actually when you run the node here with this specific configuration with C++ and Python node in the same package. Okay, because when you just create a Python package with ROS2, there are some things that are handled for you behind the hood and you don't need to worry about. But if you create like this kind of a custom package with C++ and Python, make sure you have this structure, okay, with if name is equal to main, so that you can be sure that when you launch the script, the main function is going to be called. Because we are not going to install the Python node the same way we would do with just a normal Python package. So let's save everything. Okay, everything is saved. And quick recap here, we have in the source folder of our workspace my custom package. In my custom package, we have include with also my custom package folder with the C++ headers. In the source folder, we have the C++ files. And then we have another folder with the same name as the package with init.py, so that's an empty file here, and then modules to import that you're going to put there. In the scripts folder that we have created here, we have the Python nodes that we have put as executables also. And then we have CMakeLists.txt and package.xml, which we're going now to configure. So now that we have created all the nodes, all the headers, and the modules, well, now we need to install this so that we can then compile and use the nodes. And we're going to do the configuration in the package.xml and the CMakeList.txt. And let's start with package.xml. So what do we have here? Well, we have the usual stuff with the name, version, description, maintainer, license, well, stuff like that, and then test, etc. What you can see here, we have build tool depend element CMake. This is what we have provided when we created the package. And I'm going to add here another build tool depend. So build tool depend with element. And this time it's going to be element CMake Python and build tool depend. Okay, so we are going to use element CMake and element CMake Python. Okay, make sure that you don't use here just element Python. Okay, element Python is for a standard Python package. Here we use element CMake Python, which is going to allow us to configure and install Python nodes from the CMakeList.txt. Okay, so that's a very specific configuration. Make sure you have element CMake Python. Then you can leave the rest like this. And I'm going to add also depend tags for the libraries that we use. So we use RCL CPP depend, and we use RCL Py. Okay, so any library that you need to import and use, of course, make sure you add depend tags. So what I've added is those 3 lines. Okay, element CMake Python, that's the most important, and then dependencies to the libraries that we use in this package. Let's save this, and that's pretty much it for the package.xml. Now we can install stuff by providing some instructions in the CMakeList.txt. So actually, let's clean stuff that we don't really need for now. Okay, let's just remove that. Okay. And so in the CMakeList.txt, we will have mainly 3 parts to write. The first one is to make sure we have all the dependencies that are correct. And then we're going to do the C++ part and then the Python part. So let's start with the dependencies. So we have find package with element CMake required. Actually, I'm going to just do the same with element CMake Python because, well, that's what we need and what we have provided in the package.xml. So we need that dependency. And I'm going to also add 2 more lines for RCL CPP and RCL Py. Okay, so all libraries and dependencies I need, I put them here so that we need to find a package before we can continue. Now let's do the C++ stuff. So for C++, we will need first to include the CPP include directory. Okay, so I'm going to add a comment on top of each section here. So include directories, include. By doing this, I make sure that I include which one? That one. Okay, so we are inside the package. You can see here in project my custom package, we are inside this package. By doing include directories, I include that directory right there so that I can include then the header files. And so if you go to source CPP node, you can see I do my custom pkg/cpp header. This works because of that line. We include the include directory, so then we can find from there my custom pkg, which is that folder, and cpp header.hpp. All right. And then let's create cpp executable executables. So quite standard stuff here. Add executable. Let's name it cpp exe, and then this one is going to be in the source / cpp node.cpp. Okay, so that's the path. Okay, directly from the package. That's where the node is. And then I will also need to do aimant target dependencies. So cpp exe, I will need to add rcl cpp because that's the library that we need inside the node. Okay, so we have the C++ executable, and now we need to install cpp executable, because if it's just compiled, it's not going to be installed. So we need to install it, and let's do install. So that's quite also common to C++ nodes, so I'm not gonna spend a lot of time to explain this. So targets, and then let's do, so let's go like this and do a new line. Let's do cpp exe. Okay, so that's the executable we have created, and we're gonna put that with destination here, lib / and then let's use project. So $, and then curly brackets, project name. Project name is actually that, my custom packaging. So with this, we will be able to actually start the executable. It's going to be installed, and we will be able to start it with ROS2 run. All right, so that's it for C++. Now let's do the Python stuff. And this is something that you would not do in a standard C++ or a standard Python package. Okay, that's very specific to this use case. So we are going to first install Python modules. And to do that, I'm going to do aimant Python install packages with project name. So this will install the modules with project name, and project name is actually the name of the package. So this will install the module that we have in my custom package. So that's why I've created the same name here, because we're going to use the name of the package. Okay, so the modules here will be installed, and we can find them from the nodes. So very important. This line is kind of the same basically as the include directories here for the C++ header files. Okay, and now we don't need to actually compile, we don't need to create executables, because we already have executables. Okay, that's Python. So we already have an executable here. And so we're gonna install Python executables. And to do that, we just do also install, and I'm gonna use programs, and we're gonna follow the same, basically the same structure as here for the C++ executables. So this time I need to provide the path here to the py node, so script / pynode.py. And where do I install this? Well, destination lib / and then $ project name. So basically, I will install the Python executables and C++ executables in the same install folder. All right, so that's quite a few steps, but once you have done this, then adding any new C++ executable or any new Python executable is going to be very easy. Okay, you just need to add some files here and add just one or a few lines in this configuration. Okay, so we have first dependencies and then C++ stuff, so include the right C++ folders, create executables, install the executables. For Python, we install the modules, and then we install the Python executables. Now I'm going to save this, and let's try to compile and to run those two executables that we have here. So let's see if everything we did is working. So let's go back to the ROS2 workspace, and let's do callcon build. Okay, do packages select with my custom package. Let's see if that works. And we have an error which actually is here, so it's not well, it's not packages, it's Ament Python install package. So sorry for the mistake here. I'm gonna try to compile again. Maybe if I save the file, it's gonna be better. Okay, so it's been compiled, and let's actually see. So now we have the install folder. In the install folder, we have my custom package, and in this we have a lib folder. So let's go to lib and another my custom package, and you can see in this lib/package name folder we have the executable C++, so cpp.exe that we have created in the CMakeList, and PyNode that we have installed from the CMakeList. Great. So now, well, let's open a new window actually, and so this is going to source the bash rc and source the ROS2 workspace. Okay, you need to do that. And now I can do ROS2 run my custom package. I press tab twice, and you can see now I can run cpp.exe. Okay, test cpp node. So I have run that node, Control C, and then let's do the same with PyNode, and boom, that's working. We have run the Python node, and so we have created a C++ node and a Python node from within the same package. So as you can see, that's not that difficult. As long as you clearly separate the Python files here and the C++ files, you should be fine. Make sure you double check the configuration, of course. And well, if you want to install any other things in the package, for example, launch files, YAML files, etc., like configuration files, well, you just need to install them as you would install them in a standard C++ package. So nothing really different for that. If you liked this video, subscribe to get more tutorials like this in the future. Also, check out my online courses so you can learn ROS2 step by step in an efficient way by practicing and directly going to the point. Links in the description. Alright, thank you for watching. See you in the next tutorial or in one of my courses.